Welcome to our comprehensive guide on C++. In this video, we'll take you through the essentials of C++, one of the most widely used programming languages in the world. Whether you're a complete beginner or looking to brush up on your skills, this series will help you understand the basics, key features, and practical applications of C++. Let's start by exploring what makes C++ unique and why it remains a popular choice for developers across the globe. C++ is a general-purpose, case-sensitive, free-form programming language that supports object-oriented, procedural, and generic programming. Developed by Bjarne Stroustrup in 1979 at Bell Labs, C++ was initially called C with classes before being renamed in 1983. It's a middle-level language combining features of both high and low-level programming, and it runs on various platforms like Windows, Mac OS, and Unix. C++ is a superset of C, meaning most C programs can run in C++ without modification. Story of C++ begins with Bjarne Stroustrup at Bell Labs in Murray Hill, New Jersey. He started developing C++ in 1979 as an enhancement to the C language, aiming to add object-oriented features. Originally named C with classes, it was later renamed C++ in 1983, with the ++ symbol representing the increment operator in C, signifying the language's evolution. C++ has since become a foundational language in software development, influencing many modern languages. C++ stands out for its simplicity, rich library support, and blazing execution speed. Programs can be broken down into logical units, making them easy to manage. While C++ executables are machine-independent, they are platform-dependent, meaning compiled programs on one OS won't run on another. Its mid-level nature allows both system-level programming and large-scale application development. C++ also offers direct memory access through pointers, object-oriented programming, and is a compiled language, contributing to its speed. C++ is everywhere in the software world. It's used to develop major operating systems like Windows, Mac OS X, and Linux. Core parts of browsers such as Mozilla Firefox and Chrome are written in C++. MySQL, a popular database, is also built with C++. C++ has been instrumental in developing new programming languages, scientific computation game engines, and embedded systems, including medical and engineering applications. Its versatility and performance make it a top choice for developers. One of C++, defining features is its support for object-oriented programming, OOP. OOP helps create maintainable and extensible programs, especially as codebases grow. The four pillars of OOP in C++ are encapsulation, data hiding, inheritance, and polymorphism. These concepts allow developers to build large-scale applications that are easier to manage and extend, setting C++ apart from its predecessor, C. C++ comes with a robust set of standard libraries, making development faster and more efficient. The core language provides building blocks like variables and data types. The C++ standard library offers functions for manipulating files and strings, while the standard template library, STL, provides powerful methods for handling data structures. These libraries are essential for rapid and effective software development. Do you know the name C++ reflects its evolutionary step from C, with ++ being the increment operator? C++ is a dominant language for technical and commercial software. It introduced object-oriented programming to the C family, borrowing OOP features from Simula 67. Every C++ program requires at least one function, typically main. C++ programs are collections of objects that interact through methods, making the language both powerful and flexible. In C++, objects are instances of classes. Think of a class as a blueprint and objects as the actual items built from that blueprint. Objects have states and behaviors such as a dog's color or its ability to bark. Methods define what an object can do while instance variables store its unique data. This structure makes C++ programs organized and scalable. Let's look at the classic Hello World program in C++. This simple example demonstrates the basic structure of a C++ program, including comments, header files, the main function, and output statements. Understanding each line helps you build a strong foundation for more complex programs. The program starts with including the IOStream library, uses the main function as the entry point, and prints Hello World to the screen using count. Every line in a C++ program serves a purpose. Comments provide explanations, while directives like hash include bring in necessary libraries. The main function is where execution begins. Statements end with semicolons, and indentation improves readability. Output is handled by count, and return 0 signals successful execution. These conventions ensure your code is clean, organized, and easy to maintain. C++ handles input and output through streams. Input streams bring data from devices like keyboards into memory, while output streams send data from memory to devices like screens. The IOStream library defines objects like sin for input, count for output, ser for errors, and clog for logs. These streams make it easy to interact with users and handle data efficiently in your program. Count object combined with the operator displays output on the screen. You can chain multiple outputs in one statement and use endl to add a new line. For input, sin uses the operator to read data from the keyboard. You can read multiple values in a single statement, making user interaction straightforward and efficient. C++ provides ser and clog for error and log messages. Ser is unbuffered, meaning output appears immediately, making it ideal for error reporting. Clog is buffered, so output may be delayed until the buffer is full or flushed. Using these streams helps separate regular output from errors and logs, improving program clarity and debugging. Keywords are reserved words in C++ that have special meaning and cannot be used as variable names. There are 32 keywords inherited from C and 30 additional ones unique to C++. Examples include int, float, class, public, and virtual. Knowing these keywords is essential for writing valid and effective C++ code. Comments are used to explain code and make it more readable. C++ supports both single-line comments starting with and multi-line comments enclosed between asterisk and. Comments are ignored by the compiler and are essential for documenting your code, making it easier for others and yourself to understand and maintain. C++ supports a wide range of data types which determine the kind of data a variable can store. These include primitive types like int, char, float, and bool, as well as derived types such as arrays and pointers and user-defined types like classes and structures. Choosing the right data type is crucial for efficient memory usage and program performance. Primitive data types are built-in types that can be used directly. These include int for integers, char for characters, bool for Boolean values, float for single precision decimals, double for double precision decimals, void for valueless entities, and wchar-t for wide characters. Each type has a specific memory size and range which may vary by system. Derived data types are built from primitive types and include arrays, pointers, functions, and references. User-defined types are created by programmers and include classes, structures, unions, enumerations, and typedefs. These types enable you to model complex data and behaviors, making your programs more powerful and flexible. The sizeof operator is used to determine the number of bytes a variable or data type occupies in memory. For example, sizeof int returns 4 on many systems. This operator is essential for writing portable code and understanding how your data is stored and managed by the compiler. C++ allows you to modify data types using keywords like signed, unsigned, short, and long. These modifiers change the range and size of the data type, allowing you to optimize memory usage and handle specific data requirements. For example, unsigned int can store only positive values, doubling the maximum value compared to a signed int. Identifiers are names used to identify variables, functions, classes, and other items in your code. They must start with a letter or underscore and can contain letters, digits, and underscores. Variables are named memory locations used to store data. Following numbing rules and best practices ensures your code is clear and error-free. Scope determines where a variable can be accessed in your program. Local variables are declared inside functions or blocks and are only accessible there. Global variables are declared outside all functions and are accessible throughout the program. Properly managing variable scope helps prevent bugs and keeps your code organized. When you declare a variable, it's important to initialize it with a value. Local variables are not automatically initialized and may contain garbage values. Global variables, on the other hand, are initialized to 0 or a default value by the system. Always initialize your variables to avoid unexpected results in your programs. Operators are symbols that perform operations on variables and values. C++ includes arithmetic, assignment, comparison, logical, and bitwise operators. For example, the plus operator adds values while == checks for equality. Understanding operators is fundamental to writing effective and efficient C++ code. Arithmetic operators include plus, asterisk, slash, percent, plus, and for basic math operations. Assignment operators like equals, plus equals, asterisk equals, and slash equals are used to assign and update variable values. Mastering these operators allows you to manipulate data and perform calculations efficiently in your programs. Comparison operators such as equals, greater or equal, and lesser equal are used to compare values and return true or false. Logical operators like and, or, and not help you build complex conditions in your programs. These operators are essential for decision-making and controlling program flow. C++ provides a variety of built-in math functions through the CMath library. Functions like max, min, sqrt, round, and log allow you to perform advanced mathematical operations easily. These functions are essential for scientific, engineering, and financial applications. Manipulators are special functions that modify the input-output stream, allowing you to format data display. Common manipulators include endl for new lines, setwa for setting field width, setfill for filling spaces, and setprecision for controlling decimal places. Including IMANIP gives you access to these powerful formatting tools. C++ provides several ways to make decisions in your code. The if statement tests a condition and executes code if the condition is true. You can extend this with if else, nested if, and if else if ladder statements to handle multiple conditions and outcomes, making your programs responsive and dynamic. Switch statement allows you to select one of many code blocks to execute based on the value of an expression. Each case represents a possible value, and the break keyword exits the switch block. Switch statements are useful for handling multiple discrete options such as menu selections or command processing. Loops are essential for repeating actions in your programs. C++ supports for, while, and do-while loops. For loops are used when the number of iterations is known, while and do-while loops are better when the number of iterations depends on runtime conditions. Loops help you write concise and efficient code. For loop is a repetition control structure that executes a block of code a specific number of times. It consists of initialization, test, and update expressions. For loops are ideal for iterating over arrays or performing actions a set number of times, making them a staple in C++ programming. Loops execute as long as a condition is true, making them suitable for situations where the number of iterations isn't known in advance. Do-while loops are similar, but the loop body executes at least once before the condition is checked. Both loops are powerful tools for handling dynamic and user-driven processes. An infinite loop is a loop that never ends because its condition always evaluates to true. While sometimes intentional, infinite loops are usually errors and can cause programs to hang. Always ensure your loops have proper exit conditions to prevent unintended infinite execution. Functions are groups of statements that perform specific tasks. Every C++ program has at least one function main, but you can define your own to organize and reuse code. Functions improve code readability, reduce repetition, and make programs easier to maintain and debug. A function declaration tells the compiler about a function's name, return type, and parameters. The definition provides the actual code. Functions can return values or be void if they don't return anything. Declaring functions before main helps organize your code and avoid errors. To use a function, simply call it by name followed by parentheses. Functions can be called multiple times, making them ideal for repetitive tasks. Parameters allow you to pass data to functions, and return values let you get results back. This modular approach keeps your code clean and efficient. C++ supports two main ways to pass parameters to functions: pass by value and pass by reference. Pass by value copies the data, so changes inside the function don't affect the original variable. Pass by reference allows the function to modify the original variable, which is useful for large data structures or when changes are needed. You can specify default values for function parameters in C++. If an argument is not provided when calling the function, the default value is used. This feature makes your functions more flexible and easier to use, especially when some parameters are optional. Storage classes define the lifetime and visibility of variables and functions. C++ supports automatic, register, static, external, and mutable storage classes. Each class affects how and where a variable is stored, how long it exists, and where it can be accessed. Understanding storage classes helps you manage memory and program structure effectively. Arrays are collections of elements of the same type stored in contiguous memory locations. C++ supports single and multi-dimensional arrays. Arrays allow you to store and manipulate large amounts of data efficiently, making them essential for many programming tasks. You can pass arrays to functions by specifying the array name without an index. The function receives a pointer to the first element, allowing you to process the entire array. This technique is useful for operations like finding the minimum or maximum value or calculating averages. Pointers are variables that store memory addresses. They are powerful tools for dynamic memory allocation, efficient data manipulation, and interacting with arrays, functions, and structures. Understanding pointers is crucial for advanced C++ programming and optimizing performance. Structures are user-defined data types that group variables of different types under a single name. They are useful for modeling real-world entities such as books or records. Structures can be passed to functions and manipulated just like other variables, making them a versatile tool in C++ programming.